So the idea of a confidence interval is when we are making an inference about a population average or a population proportion or something about the population, and we're basing that on a small sample, we recognize that the sample average or proportion or whatever it is may not be exactly the same as the population, but it does certainly give us information about the population. So what we can do based on how spread out the sample is, we can start to get a sense of where we're pretty sure the population average or proportion or whatever is, and it's in some kind of range. So instead of just giving a single value, we give a single value plus or minus a certain thing called the error margin, that plus or minus. We've seen that in polling and survey, political polls. So that range there is the estimate that we're pretty sure the population value is based on what we see in the sample. So let me go through an example here. So a random sample of the entire country was asked, where do people, or sorry, how do you view God? First they were asked, sorry, I should clarify. First they were asked, do you believe in God or a higher power? And if they said no, they were not asked this question. If they said yes, they do believe in a God, then they were asked a follow-up question on a scale of 1 to 7, with 1 being very fierce and tough, and 7 being very forgiving and loving. Where do you view God? Where is your view of God? And so there are, all kinds of answers. The average was 2.9 something. So people tended, on average in this country, to view God more as this fierce, powerful God than a loving, forgiving God. And I think probably the question could be tricky because you could view God as both. But I think it was more like on a scale of 1 to 7. So even if you did view it as both, maybe there's a certain direction that you view God a little bit more. In any case, the results for the entire country was this confidence interval. It was a 95% confidence interval, and it ranged from 2.86 to 3.08. And there were like 2,000 people surveyed, but it was a random sample, so it really did fairly represent the country for the most part. What does that mean? Does it mean that 95% of people who believe in God view God between these two numbers somewhere on the scale? Or maybe 95% of our sample means, if we were to take lots and lots of these samples of size 2,000 that are averages? Or we're 95% sure our sample mean for our 2,000 people were between that? Or the sample represents 95% of the population? No, no, no. None of these are right. So don't tie into any of those too much. The answer is we're 95% sure that that population average, that's what we really wanted. We didn't want the view of those 2,000 people. We wanted the view of 320 million people, or at least the portion of them that believed in God. We wanted to know where they would put God on that spectrum. And we can be 95% confident based on this survey that whatever that true average is, there is some average out there. You take all the people in the US, get the ones who believe in God, have them rate God on a scale, and then average the numbers. We That would be really, really expensive and hard to do, but you could do that. Whatever that magical number is, we're 95% sure it's somewhere between 2.86 and 3.08. In other words, we can be very, very confident that on average, people tend to view God more as a fierce God rather than a loving and forgiving God. Um, so we could also say that 95% of the confidence intervals will contain the true population average. In other words, if we would take another 2,000 people and get another confidence interval, maybe 2.9 to 3.15 or something, and we kept repeating this process over and over, 95% roughly of those confidence intervals would have whatever that true magical population mean is, somewhere in between the two numbers. And then 5% wouldn't. So there's also another way to look at that. There's also 5% of the time, the true average is going to be a little bit lower or a little bit higher, probably not that much beyond, but it might be, 2.84 or 3.12. In any case, we can be very confident it's below 4, but there is a chance, 5% chance in average that population mean would be somewhere outside. So yeah, none of these others are true. It doesn't tell you anything about the percent, a certain percent of people. It's telling you about the population mean. It's about a magical number. That true population mean is what the confidence interval is giving you information about. And by the way, we can be 100% sure our sample mean is between these two numbers. The sample, the 2,000 people, because the sample mean is your best prediction of the population mean, and then you go that plus and minus the error margin. And that confidence interval is kind of built around the sample. So the sample mean has to be in there. It's right in the middle of it. Whether or not the population mean is between these two numbers, well, we're 95% sure it is. Okay, so here's a question to give you. This is actually from the textbook we used to use. Well, it didn't say EMU students, but basic idea. So we have EMU students, we have a sample of them that we collect, and we get this 95% confidence interval. Don't worry so much about the T, it's just a special type of confidence interval. And we're trying to figure out the average number of hours that EMU students study per week. So this is, again, we could take every single EMU student, 1,800 of them, or whatever it is right now, get the number of hours they report studying per week, and then average all those numbers. Whatever that magical number is, that's what we're trying to estimate. And based on our sample, if we do get a good random sample and get a confidence interval here of 3.5 to 7.2, what that tells us is we're 95% sure that the average number of hours an EMU student studies per week is between 3.5 hours and 7.2 hours. It doesn't say 95% of the students will be in between those two numbers, not at all. But it says 95% sure or confident that true average of all students is somewhere between those two numbers. So if you're curious how we actually get that confidence interval, I mean, there is a formula that involves standard error, which we haven't really talked about. But we can also use the formula confidence T, so we want that. And then we want to start off, if we click this here, with the alpha level. So alpha is 1 minus the level of confidence. If we want a 95% confidence, we have 5% alpha. 90% confidence, we have a 10% alpha. And standard deviation would just be the standard deviation of our data there. And then the sample size is just the size of our sample, which in this case is 10 data points. And what does that give us? 1.588. So what that gives us is the error margin. This is the amount that we would subtract from the sample mean. So we take this minus this to get our lower end of that confidence interval. And it's also the amount we would add to the sample mean to get that upper part of the confidence interval. So this formula right here gives us the error margin, and then we subtract and add that to our sample mean, which is really our best guess at the population mean. But like I said, we know that population mean could be a little off in either direction. That's why we add and subtract there.